This is Dave Brown, and I'm here with Bennett Mortensen, who is an expert in prototyping. He's run a consulting business, and he also works here in tech transfer at BYU now. So, Bennett, can you tell us a little bit about yourself and kind of your background in engineering and prototyping?
Yeah, absolutely. So I graduated from BYU with both my undergraduate and graduate degree in mechanical engineering. I've had a wide array of jobs over the last few years, but most recently I started a consulting company working with small businesses, startups, entrepreneurs, focusing on the development of their technology into kind of the MVP stage of development for their business and helping set up manufacturing and supply, on the technology side.
Okay, and I know a little bit about what you did in the engineering program here. You were working on the Mars rover project. Do you mind talking about that for a second?
Yeah, absolutely. So that was part of my undergraduate capstone kind of senior year project. Really fun program that BYU does, the Mars rover competition. I believe they do it every year. The year that my team competed, we actually got second place, which was fantastic. We were going for first, but we'll take second. And for that competition, I can't remember every single detail of it, but you basically build I believe it's semi-autonomous now. Before it was all robotically controlled, and so you build a rover, you have a set of challenges, both terrain, kind of an obstacle course, as well as robotic arm manipulation of switches and knobs, different things like that. And then the communications part of it, which is we had, electrical engineers for that portion. You also have to be able to control everything remotely. So really fun project, takes place here in Utah. So we were happy that we got accepted. That would have been a little embarrassing not to be accepted, but yeah, really cool project.
Well, super fun. So a lot of BYU students do real hands-on projects like that, and that's an interesting part of education. Experiential learning is the term here. And in your work, doing prototyping, that is very hands-on. You're creating something tangible. Just for those of us who don't know, can you tell us what is prototyping generally? If a client asks you to do that, what are you doing for them?
Yeah, so it depends on what they need, honestly. So prototyping, you can think of it in terms of maybe fidelity, right? So you'd have really high fidelity, which would be like a finished product that you're going to ship out to a customer, and then you'd have really low fidelity, which the purpose of that would be to accomplish something specific. So maybe you want to test out the size of the device, maybe you want to test out maybe the form, the general aesthetics, maybe you want to do something there. So really when we say prototype, it is maybe, to try to come up with a simple definition, would be kind of a physical, and maybe not even physical, right? But just a representation of the product in some form of some level of fidelity to give you insights into either decisions that need to be made or next steps in the development process.
Okay, and in your consulting business, who would be a typical client? Were these entrepreneurs just figuring out a product, or these more established companies that are?
Yeah, so typically entrepreneurs. I was focused and geared towards small businesses and startups. So it would be an entrepreneur who had an idea for a product and they needed technical assistance in developing that product, prototyping that product, and then setting up the manufacturing for that product, right? So typical customer would be somebody, hey, I've got a great idea, right? They'd come to me, say, this is my idea, this is what I'm thinking, a little bit of back and forth on maybe how we could lay out a plan towards success, and then I would take care of the engineering, prototyping, development, manufacturing, and then help set up the supply chain to get them to that MVP, that minimum viable product, to the point where they could then start selling that product.
Okay, so if I'm a student entrepreneur or any entrepreneur, and I could be licensing from tech transfer, getting a technology here, or maybe I've just invented my own thing and it's a widget. There's so many things to do with the business. I should probably be raising money. I should probably be doing some marketing, like all these other aspects. How much time should an entrepreneur put into actually creating the prototype?
It depends on their skill set, right? So if they are skilled in it, if they're the technical founder of the company, right, they're going to put 100% of their time into kind of that prototype development. If you're maybe the business founder of the company, right, you have those fundraising skills, those marketing, those, you're out there creating connections. Honestly, you want to offload as much of that as you possibly can. The learning curve is fairly steep. I've been doing engineering, schooling for 7 years, right? And there's still a huge breadth of knowledge that I barely understand, right? So if you think that if you don't have the technical skills to achieve it, but you feel like your idea is still really good, my recommendation would be to bring in somebody who has those technical skills, who has that background, who can focus exclusively on the technical development and allow you to play to your strengths on the business side.
Mm-hmm. Yeah, just generally, I think successful business leaders are conversant in a bunch of different areas. They just know enough to say the right thing to the expert in an area.
Yes,
so
yes. You definitely want to have enough technical depth that you can at least have a fairly technical conversation, but you don't have to be the expert. I think that's one thing that sometimes entrepreneurs miss is they feel like they have to be the expert, right? They feel like they have to be maybe the Steve Jobs, right? But they don't realize that behind the scenes, Steve Jobs had, I can't remember his name off the top of my head. Right? Wozniak, yeah. Exactly, right? Yeah. Like Wozniak was the technical founder in a lot of respects. Steve Jobs was as well, right? But he more had the vision and kind of long-term, this is what I want to do with the company, right? These are the pivots that we're going to take, and then relied on those with a maybe deeper technical understanding to help him realize that.
Yeah, totally right. Great book by Steve Wozniak, the book I Was. I don't know if you've ever read it, but it's his account of the whole Apple thing. And, in interviews, but also in the book, he'll be a little critical of Steve Jobs at times, saying, he was mean or kind of pushed the limit on this or that, whatever complaints Wozniak has. But he'll always acknowledge in the end, but we never would have made it as a business without Steve Jobs. So have the person doing that. Okay, but if someone does want to become a technical expert on creating prototypes, I don't even know, in engineering, what classes did you take or what did you do that taught you how to do that?
Yeah, so really, if you want to become an expert in kind of the prototyping field, the best course of action is just to go get your hands dirty, because the engineering disciplines, fantastic, a lot of technical knowledge, but the capstone portion of that knowledge, you kind of is where the rubber hits the road, so to speak, and that's where you see those who were willing to get their hands dirty throughout their schooling and those who weren't, right? Because a technical understanding of the stress and strain that's going to be, existent in the product is very different from putting the pieces together, fabrication, some of those types of skills that maybe are a little less technical, but definitely needed if you want to contribute to the prototyping and development portion of any project.
Okay.
So jumping out, getting your hands dirty, trying things, 3D printing, learning how to weld, right? Learning how to cast, learning how to do some basic woodworking skills, right? Like if you're scared of the power tool and you can't pick it up and do something, you're going to have a hard time prototyping just about anything.
Yeah. So I've thought about this. If I wanted to dabble in creating prototypes, I think what I would do is get an affordable 3D printer, go on Thingiverse, download some plans and print off some things and just try to play with it. But speaking of Thingiverse, great story from the past week. Do you want to talk about that?
Yeah, absolutely. So Dr. Howell, one of the professors here at BYU, he did a collaboration with Mark Rober, huge YouTuber. Right, really doesn't need to introduce Mark Rober. I'm sure everybody knows of him. But they did a collaboration, make the world's smallest Nerf gun. And as part of that, the files that were created by BYU as part of that collaboration were made available on Thingiverse. I think we were the #1 downloaded file, for trending files over the last couple of weeks. It's fantastic. We've had people reach out inquiring about that technology. Really cool collaboration that happened there.
Yeah, I just saw today there were over 15 million hits, and so if anything, the views seem to be increasing in speed.
Yes.
And it's still the plan is still #1 on Thingiverse. So if you wanted to mess around with prototyping, you can go print off the Nerf.
And that's a great example of it, because if you watch the video, they went through a number of different iterations of the prototype. They used different materials, they used different scaling, they had different designs, right? And what you see in the video are some of kind of the finished versions of that. But I can guarantee you that they went through dozens, if not hundreds of different design choices trying to hone in on kind of the final version of that for the collaboration with Mark Rober. So that's another thing to keep in mind with prototyping. Your chances of getting it right on the first shot are basically zero. So try early, try often, fail quickly, right? So that you can iterate and get to those, higher quality prototypes that are what you're going to see in videos like that collaboration.
Mm-hmm. Yeah, and there's BYU put out a behind the scenes video of making the Mark Rober video, and it has our students on there doing their thing. It's really great, but you can see kind of what you're talking about, the iterating and trying to figure out these things. So when you're creating prototypes, let's say for entrepreneurs, since that's mostly what we're interested in, what are some of the challenges? What are problems you run into?
So budget is always a problem, right? Like if you're a starting out entrepreneur, you probably don't have as much capital as you would like to have. And so that was part of the business that I created, was a more collaborative spirit, not charging directly per hour for the work that was being done, but more coming to terms of some sort of partnership there. But having enough funding to do the prototyping and develop the product is always a challenge. If you look to do any kind of injection molding or anything that requires a really detailed technical mold, you're talking anywhere from $5,000 to $20,000 right off the bat. Again, if you're starting out, that can make or break your business. So finding ways around that, finding creative ways to create prototypes, get things physically here in the space is always a challenge when you're starting out.
Okay, so here in the tech transfer office, we're licensing out university technologies to outside companies or startups. They might be raw technologies. Sometimes people might ask, like for you, since you're our engineering lead, maybe there's some widget that you're licensing out. A prospective licensee is going to say, well, do you have a prototype I can look at? And do we typically? Probably we do. Some kind of rough lab prototype?
Yeah, we do in a lot of cases. It's interesting, though, because depending on who you're showing the prototype to and the purpose of it, engineers, they're very satisfied with a low-fidelity prototype, right? So if you have a bunch of breadboards and wires and 3D printed parts and nothing's painted and nothing looks like a finished product, but it works, engineers are super excited about that.
Yeah.
Now, business guys, right, of taking it to invest pitch meetings, they really don't want to bring in something that's just a mess, right? Even if it is functional, it needs to be a little bit more polished. So kind of back to earlier in the conversation, understanding the purpose of your prototype is incredibly important, because in that scenario, you may have a functional prototype that's super ugly, right, for lack of a better word, and then a non-functional prototype that is beautiful, right? It looks like a finished product even though it doesn't function. Yeah. And depending on what you're trying to achieve, whether you're raising money or hiring, new members of your team, whatever it is that you're looking to do might dictate the fidelity, quality, and kind of function of the prototype that you're developing.
Okay, and so often here at BYU, I've noticed miniaturization can be a big problem in creating a prototype. The first version, so Daniel Smalley has this amazing volumetric display technology that you're working on, where he's suspending particles in the air and creating images. Really great. The first time I saw it, though, it was huge.
Right.
And now they've shrunk it down, so it's pretty small. Is that you've dealt with in your consulting business? How big a problem is that?
I don't know that that's something that I've dealt with specifically. Well, I guess in a couple of projects, there's issues when it comes to tolerances. So the cost kind of raises exponentially the tighter the tolerances need to be. And so when you're, again, starting out, you're kind of creating these products, creating a brand, it may be hard to pay for the type of tolerances that you want to have, right? Maybe a good example of this would be like a really high-end car, right? Everything's really tight, everything works correctly, everything fits correctly, everything's aligned, versus maybe the cheapest motorcycle you can buy, right? Where it's kind of cheap, nothing really fits correctly. Different markets, different purposes there. And so when it comes to maybe scaling, the experience that I have is that it needs to be workable, not perfect, right? Okay. And in a lot of kind of you think of maybe the first products from a lot of big companies, they worked, they fulfilled a market need, they did so well enough that the quality wasn't distracting, and then they used the success to build version 2, version 3, right, and really tighten up those tolerances.
Yeah, totally. Okay, well, great. So in tech transfer, what do you think is what's the right way for us to collaborate with inventors here and help them in the prototyping process? Or is that more of a problem for the licensee?
I would love to see more collaboration here in the tech transfer office. There's a huge gap in a lot of cases between research, and the point that it gets handed off to the tech transfer office, and a finished product, right? And sometimes if you're a business-minded entrepreneur, kind of filling that gap can seem insurmountable. So I would love to see us more collaborative with potential licensees, connecting them with manufacturers who are local, who can step them through kind of this prototyping and creation process for the manufacturing, and really being a resource for them. Obviously there's limitations, right? We're not going to pay for certain things. We're not going to just build things for you. But if we can help get you in the room with the right people who have the right skills to kind of take you along that path, I see that being a huge opportunity for our office in the future.
Okay. Yeah, definitely. So most inventors at universities are going to feel like they don't have funds to put into prototyping, probably because the research funding is going to the fundamental research. And then tech transfer offices have a million different things to spend money on. A lot of it's going to patenting, so they feel resource constrained. What are some good ways, do you think, to fund prototyping?
I think connecting with those who are looking for experience, right? So looking for students who would be willing to do it just to put it on their resume, right? That they created this for a company. partnering early, in that same type of situation with students or recent graduates who, again, are looking for those opportunities. I think that those are all great ways to do that, as well as determining what the purpose of the prototyping is, right? Because again, understanding the fidelity and the level of complexity that you need to present for whatever stage of the business you're in, right? If you have a good concept, maybe you can get away with a very low quality prototype and then maybe a high quality representative prototype to go look for those funding opportunities. Again, I would say be very intentional with what it is that you're trying to achieve. If out of the gate you're trying to go for production ready drawings and prototypes and all of that day one, there's a good chance that you're going to miss a lot of opportunities to capitalize along the way to that with lower fidelity, lower cost prototypes.
Mm-hmm. Okay, so in tech transfer, we spend money really easily on some things. And by we, I mean every office, not just us.
Mm-hmm.
But patenting, filing patent applications, you just see as so core to the process that we all pay for it, and it's an expensive thing to pay for.
Right.
But prototyping is one of those other things where I don't know, should we pay for that or not? Help me understand just financially, what's a sample product you might get from engineering, and how much would it cost to pay an outside party to create a prototype?
Okay, so let's see.
I know this is going to be very broad, and
yeah.
It out
So
of thin air.
It's very much dependent on the product that you're going to be creating, right? Mm-hmm. And I think so. Maybe I'll give you some categories of products. Maybe that's an easy way to do it. So if you have a simple, there's no moving parts, there's no electrical system associated with it. It's simply a mechanical device, very simple. Think of like a bracket, right? You could probably do some very low fidelity prototypes off of a 3D printer, for a couple of bucks, right? If you wanted to do some machining or manufacturing, either out of sheet metal or off of a CNC, you could probably do that for a couple $100, fairly reasonably. The more complex the mechanical device, right, the more expensive it becomes. Also, as your piece count rises, right, so your bill of material, obviously, you see maybe not exponential, but at least a linear rise in the cost as well. So if it's a single piece part, pretty simple, low cost, easy to manufacture. If it's got 1,000 different pieces, even if none of them move relative to one another, right, just the complexity of that supply chain, that might be a couple $1,000s to put that together. Mm-hmm. On the other side, if you have an electromechanical software, think of, your iPhone type of device, it's going to take a lot of time and a lot of different specialties to put that together, as well as the manufacture and the supply of all those parts. So, you could look at spending $100,000 on something like that and still end up with a non-functional prototype, right? Okay. That's just setting up, molds and bringing in components, and maybe your software doesn't work correctly. You can spend a lot of money very quickly, and so I think that's why, from a tech transfer perspective, the value in the patent is very apparent, right? Very obvious, and then transferable to others who are looking to license that technology. Mm-hmm. When it comes to the prototype, right, and it really needs to have a specific use case, right? What are you trying to achieve with that to justify the cost that goes into it? I think in a lot of cases it is justifiable, but again, it needs to be clear. Yeah,
so I do our software licensing here, and I'm never going to have a tangible thing to show anyone.
Right.
I always just have to talk about these things. Well, I can have screenshots, I could have an app or something like that to show people, but even there, the software usually won't be fully developed. So I'm kind of out of the running on this. But as our engineering lead, so it sounds like some of your technologies, it's just not even worth prototyping. They're so complex that it's not realistic for probably any use that we would do.
Right.
But for simple things, I do see that if people walk in the office, or if you're at some kind of meeting with potential investors, potential licensees, if you had a table with a bunch of objects on it, that probably does help you license a lot.
It does, right.
So what are your thoughts going forward?
Yeah,
what's your philosophy?
I think that there's an opportunity to take some of the technologies that we have, and where appropriate, to do some prototyping that's low cost for us, right? We have access to some of the university resources here. Mm-hmm. It'd be great to walk into some of those licensing meetings or set up some of those opportunities with appropriate fidelity prototypes available for those conversations, mm-hmm. right? In some cases they will work, right? They will have the functionality that they need to kind of demonstrate the technology. In other ways, it'll just be a way to visualize kind of the future state of where this technology could be, and then talk mm-hmm. about, all the research that's gone into it. So I definitely see a huge opportunity there. And even with the software, right? if we could progress some of those into an app, right, that somebody could download on their phone to, test drive the technology,
right,
that could be a huge improvement's maybe not the right word, but something that's different that could maybe, strike that spark in other individuals who maybe previously wouldn't be interested in the technology.
Yeah, in a way, it could be easy to prototype software like that.
Yeah.
But anytime you have something physical, though, if you have a prototype, then you're just worried about it working, because I'm thinking Windows 95 when it crashed when they first displayed it, hilarious. And then
Yes.
the Cybertruck for Elon Musk when the window broke when they were trying to show that. Like, these mishaps happen. Although in those cases, I don't think it slowed them down at all. If anything, it probably got them some free publicity that was helpful.
Yeah.
But if you're university tech transfer officer with prototypes, at some level, you want to be very confident they're going to work, right?
Yes, absolutely, right. So the testing that goes into that prototype before you hand it to anybody, and even just like prepping, right? So if Elon Musk had walked out and said, hey, this is eventually going to be bulletproof, ballistic glass, and then broke it on purpose, that's a much different presentation than saying this is bulletproof ballistic glass, and then it breaks, right?
Yeah.
And if you, there's reasons behind all of that, I'm sure. If anybody's kind of followed that saga, Elon Musk has his own kind of breakdown of why he thinks it breaks.
Yeah.
But again, like the confidence that you have in the prototype and the purpose of it, right, are incredibly important. So making sure that it works before you hand it to anybody is always a good rule of thumb.
So one case study for you that seems good to me is you're working on this LET joint technology, right, which maybe you can describe for a bit, but it's been used for furniture, some applications that seem very low cost. It could be manufactured here on campus. Do you want to describe that and how we would approach prototyping with that one?
Yeah, absolutely. So this is a compliant mechanism, again, developed by not only Dr. Howell, but some of the other professors here. Just Dr. Howell is probably the most visible professor that we have on campus in this related technology. And it's basically a joint mechanism that uses the compliance of the material to achieve motion. And we have several different prototypes available on campus, and I'm actually in the process right now of gathering up some of those prototypes so that we can create some promotional material. But those types of technologies are very accessible to anybody who would be looking to do some sort of startup with a low cost to manufacture, very close to a production setting, right? Like the prototypes that we have and the drawings and the designs and even some of the programming that's been done would all be available as part of that license. And it would be a very easy technology to take to market in kind of a simple iteration with the opportunity to develop the technology. Like one of the developments that Dr. Howe has worked on is flexible conformable electronics. And so that would take more development. But again, we talked about, phases. You may be able to license the technology, launch some of the more accessible things like some of the furniture that they've done, right? That would be easily accessible to the market, have kind of a defined market size and strategy there, and then use the revenue there to develop the technology into some of these other industries where it could have a huge impact, and to do that as part of kind of the overarching life of that technology.
And the demo I've seen of it, it's, so if I'm understanding, it's a sheet of wood. It looks like thin, low-cost wood. I'm not sure what kind it is. Yeah. And then they cut, for a portion of it, they'll cut these grooves, cut little pieces out of it. I don't know if the cut's all the way through or not, but in certain places, and as a result, in those places, material you think of as being stiff normally bends freely, so you can shape it into furniture or whatever else you want.
Yes,
it's basically the idea, right? So something like that, it'd be hard to even understand it without seeing it. So that's kind of the best argument for a prototype, right?
Yes. Yeah.
Okay. And if you have some of those sitting around, people are going to notice. Okay, well, good. So the prototyping industry, you've been in it for a few years. What kinds of trends? Obviously, 3D printing seems like a pretty good, solid trend over the past 10 years. But what other trends are there that are affecting how we might do this going forward?
Yeah, so the availability of 3D printing is definitely increasing. The quality of the 3D printing has also improved greatly over the last few years. And then the materials that are available for 3D printing, speaking of which, we also have some licensable technology for 3D printing in metal that is available from BYU, but all of those things are advancing very, very quickly. So that's, obviously probably the biggest trend is just the accessibility that, everybody now has to do some of their own prototyping with the 3D printing. So that has, that's probably the most relevant trend that I can think of. But also just the availability and maybe globally some of the trends in manufacturing shifting, maybe away from China in some aspects and more towards, localized. There's a ton of people in Utah who are doing startup manufacturing businesses, kind of made to order type stuff, I've been really surprised and impressed by the accessibility that I've had to local kind of small businesses who are really willing to work with you. And so I think the visibility of a lot of those businesses, the websites that they have, the programs that they have to process really small orders, right? Historically, if you had something that you wanted to manufacture traditionally, you would have to place a large order if you wanted any kind of discount. But with software advances, manufacturing advances, and even just mindset changes in lean manufacturing, a lot more of these companies are more able to quickly adapt to, here's a drawing, 3-day turnaround time, you've got yourself something physical that you can get your hands on. That's been a huge step in the right direction, in my opinion, into the opportunity that everybody has to do prototyping on their own and in small batches at a reasonable cost.
Okay, so as a result, like some products, 20 years ago, if we got some widget from engineering here, we would say, okay, well, we need a company to gear up and print this and then sell widgets to people. But now there's another faster avenue, right? If we have a good 3D model of something, maybe we could share it online somehow, give it away on Thingiverse, or charge for it some other way and commercialize it like that. What's the prospect for making money from commercializing technologies in that way?
I think it's definitely an avenue for success. Obviously, it's going to be technology dependent, right? Depending on the size and the complexity and the market that you're looking to go into. But I think that there's plenty of opportunities to kind of maybe test the waters of the market through a really low-cost manufacturing method like 3D printing, get some sales, right? Kind of see where you might be able to go with it, and then use that as a jumping-off point for additional funding or additional development of the product itself. So no, I think that's a very good path to success for the right technologies. Absolutely.
Mm-hmm. Yeah, so that's one of many things we can experiment with going forward. The closest thing we've done to that, print on demand for printed materials was kind of the same sort of thing.
Yeah.
That people have gotten used to buying things that way. So one of our professors came up with a card deck that we wanted to commercialize, and we tried shopping at the various companies. The card deck companies, therapist companies, places like that were not interested in it. So we ended up just hiring someone to have it manufactured. This was not like print on demand, but manufactured in China, and then listed on eBay and sold it. So that was a good experiment. I'd like to do more things like that. Maybe we could do it with engineering things as well.
Yeah, I think so. Case by case for sure, but I think so.
Okay, well, great. So for people who want to get into prototyping, say if there's a student who's listening to this and saying, I may or may not want to be entrepreneurial, may or may not want to work with tech transfer, but prototyping sounds interesting to me, what do you recommend they do?
I would recommend getting out there and starting it, reaching out. More than welcome to reach out to myself or anybody in the office. We can maybe point you in the right direction, kind of give you some tips and tricks on to where to get started, maybe some pitfalls to avoid. But just don't be nervous, right? Like, you're not going to mess anything up, especially if it's your own idea. Sometimes it can be overwhelming jumping in, and with any kind of project, there's a million different ways you could manufacture it. And so just not being worried about making those mistakes, jumping in. And if you can, find a mentor, right? Somebody who's done it before, somebody who maybe has access to some of the tools and the equipment and the expertise that you might need. A lot of these maker communities, they're very open, very willing to give advice and access to equipment if you're willing to get out there and make those connections.
Yeah, and at BYU, this is probably a trend at universities, but our new engineering building, new as of a couple years ago, I think, has a lot of nice features. Downstairs, it is kind of a maker space. Have you wandered over there? Like, what do they have down there for students?
Yeah, so the engineering building is actually a fantastic resource. So I believe you do have to be an engineering student, or at least part of that system. But they have an entire shop, right? A machine shop down there with lathes, mills, casting equipment. They've got welding equipment. They've got 3D printers. Obviously, you need training on some of these things, right? They're not just going to open the doors and let you go crazy. But, if you're persistent and, if you're an engineer, you have access to all of those resources. In my opinion, sometimes they're underutilized, right? A lot of times You'll walk by and there's maybe one person in this giant, space full of equipment. Get in there. There's lab supervisors who will help train you on the equipment, show you how to do it. They can help you with CNC programming. We have access to a water jet. We have access to a plasma cutter. We have access to a laser cutter. We have access to a CNC router for, wood. There's so many things that we have access to. So if you're a student specifically here at BYU and you're in the engineering college, definitely make sure that you're aware of all those and utilizing them. And again, we're not encouraging people to make mistakes, but don't be scared of making mistakes, right? We understand that everybody's students and that, things are going to go poorly sometimes. We don't encourage things to go poorly, but it does happen. So get in there and make things happen.
Yeah, and tech transfer offices, people like us, there are probably resources on campus where you could make some prototypes or promote your products in ways that you haven't thought of, thanks to these tools, the 3D printing and other tools that have come along.
And a lot of these communities, like there's clubs on campus that do kind of this makerspace type things. They're looking to connect you with business students, entrepreneurs, right? Sometimes it can be intimidating as an engineer to need to get out there and introduce yourself to some of these business students who seem like they're, that's all they do is introduce themselves to everybody else, is what it seems like sometimes. But, make those connections, find those people who have the skills that you don't have, right? And that you can complement with maybe some of these prototyping skills,
Yep. All right. Well, and like Bennett said, if there's anything we can do to help you out with that, let us know. And we'll be back with another episode in a week.